So here's number 65. Now, here's what they're trying to get us to think about. They're telling us that the velocity of some object falling to Earth is inversely proportional. This is what we did in class, inversely proportional square root of ks. Okay, so now here's the thinking they want us to do. This is telling us that s, the distance, is kilometers, and since this is falling, I'm thinking it's in seconds. So you gotta remember the units for this will be velocity will be kilometers per second. Okay, so isn't that ds, the distance, dt? Okay, so that's another name for the velocity. So now, if we come back here, I'm going to really replace the v with ds dt equals k. I'm going to write this as we did in class, s to the negative 1/2. So now we're going to take the derivative of this to get the acceleration, so the second derivative of the position will be our acceleration. So now I'm going to take the derivative of this, so that's going to be negative 1/2 times that constant k times s to the negative 3/2. Now here's the part that I wasn't seeing in class. We're taking the derivative of the distance with respect to time, right? That's what the velocity is. So since this is s, we got to think of this as the chain rule, or it's implicit differentiation. So we're going to write ds dt because we're going to take the derivative of s with respect to time. Okay? So now I'm going to clean this up a little bit. I'm going to write this as negative 1 over, actually negative k over 2 times the square root of s cubed times ds dt. Now we already know the ds dt is the same as the velocity, which is this mess here. So I'm just going to replace that. 2 times the square root of s cubed times that velocity, which was k over the square root of s. Now if we multiply those, we're going to get negative k squared over 2 times the square root of s to the 4th, and of course the square root of s to the 4th is s squared. And that's where they're trying to get us to see that the acceleration's inversely proportional to s squared. Okay, so I hope that helps. The piece I wasn't seeing earlier this morning was that this implicit differentiation piece where you take the derivative with respect to time. Okay, so I hope that helps.